everyone. Good morning, students. Today we are going to discuss about the topic sound. Let us see what is sound. Sound. Now, sound is one wave. See, I am talking and you are listening. Means sound wave is generated by me and which is audible to you. See, sound wave. Now, just focus on the wave. Sound is the wave. Which wave? This is this longitudinal wave. Okay. First of all, what is the wave? Let us see. Wave is disturbance created in a medium. Disturbance created in a medium is nothing but wave. Now, see, I am standing here. The area surrounded by me is one atmosphere, means which is made up of air, which is made up of some medium. Means medium is present here. Means that medium gets disturbed because of the wave which are created from my mouth. Means the medium, the air is here present in their particular order. Here, there, whatever. But what will happen whenever from my mouth wave is coming? This much portion, this much atmosphere gets disturbed. Means wave is generated. Wave is nothing but the disturbance created in a medium. Is called as wave. Or again, another definition of wave is transfer of energy. Transfer of energy without disturbing, without transferring medium, without transferring medium. See, wave is also transfer of energy without transferring medium. Means what? See, one example. In one pond, there is calm and cool water. If I throw one stone in that pond, in that water, in that calm water, then what will happen? Water changes its position. Means it gets disturbed. Water is not like as previous one. It's calm, but now it's not calm. It gets disturbed. Means some ripples are found. Circles, circular shapes are found. That is nothing but wave. Means some crest, trough. Means what will happen? Actually, this stone possesses some energy. When it acquires velocity, when I throw, then this stone possesses some velocity. Means kinetic energy is present. And that kinetic energy is acquired to that medium, particle of that medium. And that particle transfers the energy from particle to particle in all possible directions. That's why ripples are formed. See, water particles are there only. Particles are not changing their actual positions. Particles are transferring their energy from particle to particle. Now see one another example. I have this chalk piece in my hand. I want to pass this chalk piece up to last bench. Actually, I am here only. I won't move. Just I will hand over this chalk piece to the first bench student. First bench student will hand over that chalk piece to the second bench student. Second bench that will pass this chalk piece to the third bench students. Third one to the fourth one to the fifth. Likewise till last bench. Means this chalk piece is passed from student to student, from bench to bench. Actual I am here only, first bench student is on first bench only, second bench student is second bench only, last bench student is on last bench only. Actual particles are present there only. They are not changing their positions, only transfer of energy. This topic acts as an energy. This topic is passed from me to the last bench. Likewise, kinetic energy is passed from stone to that water particles. From particle to particle. That is nothing but wave. Wave is the transfer of energy without transferring medium, or the disturbance created in a medium is called as wave. Okay. Now, types of waves. Basically, there are three types of waves. First one, mechanical wave. Okay. Second one, electromagnetic wave. Third one, Navier wave. See, this is very basic. Basically, wave is divided into three types. That is mechanical wave, electromagnetic wave, and matter wave. Now see, let's focus on first type, mechanical wave. Here, for the propagation of mechanical wave, medium is required. Medium is required. It's essential. Medium is essential. Without medium, mechanical wave can't propagate. Means, see the word mechanical. Mechanical means which is related to the machine. Mechanical engineering means which is related to the machine. Machine means force comes. Means here means for getting disturbance in medium, some force is required. Whatever that force, that is mechanical wave. For that, medium is required. I will write here example, that is water wave. Water wave. Whatever the waves are produced in water, medium is required. That liquid medium, that is water. Water wave. Water is material medium. Material medium is must. Material medium is essential for the propagation of mechanical wave. Propagation means to go ahead, to move further. Propagation of wave. Okay. Sound wave is another example of mechanical wave. Sound wave. See, whatever I am talking, you are listening. This is possible because of medium. Here medium is present. That's why you are listening. Air medium, gaseous medium. The atmosphere surrounded by me is in this room. Air particles are present. Means some gaseous medium is here. That's why it's possible that wave can propagate. Sound wave can propagate. Means material medium is required here. Without medium, if suppose this room is filled with vacuum, no any gas particles, air particles are here, then whatever I am talking, you can't listen. Only you can see my lip movements. That's it. Means for the propagation of wave, whatever medium is required. Examples are sound wave, water wave. Again, one more example is the wave which is formed by string. Here, that particular string is the medium. Solid medium, whatever. Solid and liquid, solid and gaseous medium are here. For example, guitar, veena, all such musical instruments, whatever present. Means that medium, solid material medium, that string is made up of solid, and the area surrounded by that string is air. Means medium is required. Whenever that string is plucked, veena is plucked, then we can hear one sound, melody sound. That wave is propagated. The wave which is propagated on a string is whatever medium is required here. That is the mechanical wave. Here. This is about first type of mechanical wave. Now, coming to the second type, electromagnetic wave. See, electromagnetic, electron, magnet, electric field, magnetic field, both are here. Electromagnetic wave. Here, medium is not required. Medium is not required. Without medium, wave can propagate. Electromagnetic wave, medium is not essential, material medium is not required. I will write the example, that is sun rays. Sun rays. That is the electromagnetic wave, which is passing, means this is coming from sun and passing through the vacuum and enters in the atmosphere of earth. No doubt, here is the atmosphere from sea, and we know here, somewhere here is sun, somewhere here is earth. The area surrounded by the earth, this much portion is the atmosphere. Means air. See, sun rays are coming and reaching to the earth's surface. Means here, all this portion is vacuum only. It travels from vacuum and then enters into earth's atmosphere. Means here air particle, medium is here. Means it can propagate in medium, but without medium also it can propagate. That is the basic difference. Mechanical wave, electromagnetic wave. Electromagnetic wave can propagate without medium also. In medium it propagates, that is another thing. But medium, material medium is not required for the propagation of electromagnetic wave. And again, this sun rays it consists of gamma ray, X-ray, ultraviolet ray, infrared, visible rays. All are the types of these electromagnetic waves. Electromagnetic wave means sun rays. These are the other types of sun rays. Actually, electromagnetic wave is produced because of oscillation of charges. Now, I will show you one charge. If that charge is oscillating from its mean position up down, and the wave is generated, that wave is the electromagnetic wave. This is the basically oscillation of charges is nothing but electromagnetic wave. Waves are generated due to oscillating charge is the electromagnetic wave, and electromagnetic wave is transverse wave. Here I will show the diagram. Suppose this is the electric field E. This is the electric field. Then this will be the magnetic field B. This is the B. These are, and this is the E. Both are perpendicular to each other. That's why electromagnetic wave is transverse wave. We will study in detail in that particular chapter. Okay. Now coming to the third type, that is matter wave. Matter wave, which is associated with moving mass. Moving mass. Matter wave is the wave which is associated with the matter. It's called as matter wave. You see, I am on matter. I have my own mass. When I am moving, then one wave is generated in front of me, behind me. Like, see, this is one mass, one matter. Here wave is generated in this form. This is about matter wave, and this is studied in quantum mechanics. Quantum mechanics. These are about the types of waves: mechanical wave, electromagnetic wave, matter wave. Okay? Everyone, you got it? there are three types of waves: mechanical, electromagnetic, and matter wave. Three types. Okay. Now just focus on first one, that is mechanical wave. Mechanical wave. Transverse wave. Second one, longitudinal wave. There are basically three types of waves, that is mechanical, electromagnetic, and matter wave. Depending upon the medium is required, if not required. Likewise, classified into basically three types. Again, this mechanical wave is divided into two types. It is classified into two types. Why it is classified into two types? Because of the direction of propagation of wave and direction of vibration of particle. See, there are two things. Transverse wave. First, just focus on transverse wave. Okay. Here, direction of wave, direction of propagation. Propagation means to move ahead, to go ahead. Direction of propagation of wave. This is first thing. See, this is x-axis, positive x-axis, whatever. Now I am moving in this direction. Means wave, whatever wave I produce in x direction. Means direction of propagation of wave is in along x-axis. It's positive or negative, let it be. Just it's along x-axis. This is the direction of propagation of wave. Okay. Now, second thing, that is direction of vibration of field. Direction of vibration of particle. Two things. Direction of propagation of wave is propagating in x direction, along x direction. Now, second one is direction of vibration of particle. Particle means position is here. It's vibrating like this. Up, down. And wave is propagating along x direction. You got it? See. Particle is vibrating up, down, means along y direction. Direction of vibration of particle is y direction, along y direction. Whereas direction of propagation of wave is propagating in this direction, horizontal direction. Means x. It's like direction of propagation of wave is here, that is x-axis. Whereas direction of vibration of particle is here, it's y direction. Means I will draw here one wave. This is transverse wave. X-axis is nothing but direction of propagation of wave. Horizontal direction. In horizontal direction, wave is passing. And second one is that is along y direction. Vibrating. Particles are vibrating up down along y direction. Means vertical axis. The direction of vibration of particle is here and direction of propagation of wave is here. X and y axis. Both are perpendicular to each other. Means these two things are perpendicular to each other. That is nothing but transverse wave. Define transverse wave. What is transverse wave? Transverse wave is the wave means here reversed, perpendicular to the direction of vibration of particle. That is called as transverse wave. Example, just we saw, that is water wave. As already we discussed, ripples are formed in water, in calm and cool water when stone is thrown. Ripples, circular shapes are formed. In all directions, energy is passed. Upper part, lower part, upper part, lower part. That is crest, trunk are formed. We will discuss further. This is crest, this is trunk. Upper part, upper portion, crest. Lower part, lower portion, trunk. We will discuss it. Okay. Now, coming towards second type, that is longitudinal wave. Again, see, again two things in longitudinal wave. One thing is direction of propagation of wave. Propagation of wave. Direction of propagation of wave. Wave is propagating in this direction. That is horizontal direction. Whatever. Means wave is propagating along x-axis. Okay. That is along x-axis. I will show you. This is x-axis. The second thing is direction of vibration of particles. Vibration of particles. See, in longitudinal wave, what will happen? Wave is propagating along x direction, in this direction. Okay? Now, how particles are vibrating? Particles are vibrating along x direction only, from in position to and fro, not up down. That is transverse wave. Up down means along y direction. That's what. In longitudinal wave is passing along x axis, no doubt. Particles are vibrating along x direction only, to and fro, from its mean position, right, left, likewise. Means particles are vibrating, again wave is moving, propagating along the same direction. Both directions are same, that is along x axis only. That is, direction of propagation of wave is parallel to the direction of vibration of particles. Thus, I will show here the diagram. It's C, compression. Here, rarefaction. Again, it's compression. Again, here, it's rarefaction. Again, here, it's compression. Again, here, it's rarefaction. Means longitudinal wave, alternate compression rarefactions are formed. Compression, rarefaction, alternate these are formed. Whereas in atmosphere, crest, trunks are formed. Now, what is this compression? What is this rarefaction? Medium only. Compression means whenever I am talking, waves are generated, sound waves. Sound waves are generated, and due to that, air gets These are the two types of mechanical wave, transverse wave, longitudinal wave. Yes, everybody, you got it? Yes. Now, actual, we see about the wave. I will show here one wave diagrammatically. Diagrammatically represented. Its y-axis, whereas its x-axis. This upper part is called as crest, whereas this lower part is called as trough. See, where is nothing but transfer of energy from particle to particle. You just see actual its original position O. Okay, O is original position of particle. Particle is initially present here. See, we saw the example of water waves. Water wave is nothing but this way, transverse wave. Crest and troughs are formed alternately. Particles are present at their positions. When stone is thrown in that water, the water gets disturbed. Means waves are created. We know this. Actual how transfer of energy takes place, we will see here. When that stone is thrown on this particle O, then particle O acquires some energy, acquires some velocity. Then what will happen? This particle O gives energy to the second one, next particle. This particle vibrates from its new position along this y direction, comes back to the original position. Again, it gives its energy to the next second particle. The second particle is here, somewhere. Okay. What will happen? It acquires energy from previous particle and it vibrates along positive y direction in this direction. Again, come back to the new position and give its energy to the next particle. Next particle acquires energy from previous particle. Again, it vibrates from new position. Come back to the original. Again, gives energy to the next particle. Next particle acquires energy from previous. Again, vibrates along positive direction. Again, come back. Again, gives energy to the next particle. Next particle vibrates along this direction. Again, to the next particle. Likewise, vibration of particles are along y directions. Particles are vibrating along y direction. Transfer of energy along x direction. Further, again same here in this case. Here also. Along negative y direction. Again here positive, again here negative. Means particles are vibrating from their mean positions to the positive axis or negative axis. Likewise, up down, and wave is propagating in further x-axis, x direction. This is about the transfer of energy. This transfer of energy is nothing but wave. Now, there are some basic definitions, basic criteria which are required for wave, that is amplitude. What is this amplitude? Amplitude is named by letter A. Amplitude is maximum displacement of particle. Maximum displacement of particle from its mean position. Particle from its mean position is nothing but amplitude. See, particles are vibrating, means they are moving in upper y directions, in upward portion. Here also it is moving, here also it is moving. But see, where is the maximum displacement? Its maximum displacement. Maximum displacement is at the center of this crest. This is called as amplitude A. This much position. Maximum displacement of particle from its mean position is nothing but magnitude A, and its unit is centimeter or meter. Okay. Now, second one, time period. Now, time period. Time period is denoted by letter capital T. Time period. The time, total time required to complete one cycle. Here is one cycle is completed. Again, here if we move, this is second cycle. This much portion, time required to complete one cycle, is called as time period T. Time required to complete one cycle. One cycle. This is one cycle. Half part and this half part. Total part. One wave. This is half wave. This is half wave. Time is required to complete one cycle is nothing but time period capital T. And its unit is the second. It's measured in second. This is about time period. Now, further one, that is the frequency. Frequency, I will write here. Frequency, which is denoted by letter N or nu. N or nu. Frequency is nothing but number of cycles per second. Cycles per second or per unit time. That is 1 by T. And its unit is hertz. See, frequency. Frequency means in one time period, whatever the number of cycles are producing, that is nothing but frequency. For that, just I will draw here one diagram. See, this is one wave, and the time required to complete one wave, that is time period T. Okay? Its frequency N1. Now, again, in 1 second, in time period T, here I will show you 2 cycles. Means in same time period T, 2 cycles are passing here, N2. N2 is equal to here 2 hertz, whereas here N1 is equal to 1 hertz. Means N2 is greater than N1. We can see it. Means in 1 second, in unit time period, in the same time period, I mean here also 30, here also 30. Let's suppose it's 1 second. In 1 second, here 2 waves are passing, 2 cycles are passing. That's why the frequency is more. Frequency of second wave is greater than first wave, as here only 1 wave is passing. This is about the frequency. See, some students daily they are coming from home to the college and again go back to their original positions. Means one cycle is completed per day. One cycle means their frequency is 1 hertz. But some students, they are coming from home to the college. Again in long break they are going to the home, again coming to the college. Again to their original position, to their home. Means 2 cycles are producing by them per day. Means their frequency is 2 hertz. But some students they are going in long break, in short break. Again they are coming in morning and going in evening. Means total 3 cycles. Daily they are producing 3 cycles per day. Means their frequency is 3 hertz. Means see, in our class some students are here whose frequency is 1 hertz, whose 2 hertz, whose 3 hertz, and some students are not coming. At that time their frequency is 0 hertz. See, this is about the frequency. Now, next one. Okay, coming towards the wavelength. one wave. This much distance is nothing but lambda, or this much gap is nothing but lambda. So this is lambda. The length of one wave is nothing but lambda. This is simple definition, but actual definition of wavelength is the successive difference between two particles. The successive difference between two particles which are in same state of oscillation. It's very important. Which are in same state of oscillation. Same state of oscillation or vibration. See, this is lambda, or I can say this crest to crest, this much distance is lambda, or trough to this trough, this much distance is lambda. The successive difference between two particles which are in same state of vibration or oscillation. See, here particle is at mean position. Again here particle is at mean position. This much distance is nothing but wavelength lambda. Or see, particle is here at top on the crest. Here also at top on the crest. Means from this state of oscillation is decreasing. Here from this state of oscillation is decreasing. Both are in same state of oscillation. That's why this is lambda wavelength. Or see, trough to trough. The distance between trough to trough is wavelength lambda. That is, particle is here on the top of trough. From this state of oscillation is changing in this direction. Here also it is changing in this direction. Successive difference between two particles which are in same state of oscillation. That is nothing but wavelength lambda. The length of one wave is wavelength, or the crest to crest distance is wavelength, or trough to trough distance is nothing but wavelength lambda. This is about the wavelength lambda. For one wave, to complete one cycle, one time period is required, that T. For half wave, T by 2 is required. Here, this much is T by 2, or this much distance is lambda by 2. Half portion, half wave, total wave lambda, half wave lambda by 2. Total time period T, half time period T by 2, or 1/4. Means this is half. This much portion, this to this much portion is lambda by 4, or T by 4. This much part. Okay. This is some basic definitions regarding the waves. Okay. Do you got it? Okay. Remaining